Hey everyone, hope you all are doing great and welcome to our another episode today by Kunal Das. Before we start our event, let's go through our code of conduct. And yes, my name is Partharu. I'm events and program manager for Microsoft Reactor. Before we start our event, please go through our code of conduct. We are all here to learn together, participate together. So please be respectful of other people's views, understanding the differences, be kind and considerate in a way we all engage. Yes, we do encourage you all to participate. Please drop all your questions in the comment section and we'll pick it up from there. Now, I would not like to delay further. I would like to bring in our speaker for today's session. Hey, hi Kunal, how are you?
Yeah, hi Parth. Thank you. I'm doing good. What about you?
All well, doing great. Sounds like today's breakfast with Azure Container Apps.
Yeah. And I started using container apps when it was in public preview. Since then, I have been enjoying this a lot. So thought about it, sharing with the audience. Hopefully, they can enjoy.
Great, Kunal. Sounds exciting. The floor is all yours.
Yeah, sure. I'll start. Uh, hi everyone. Today we're gonna talk about Azure Container Apps, and Container Apps is basically a toned down version of AKS or Azure Kubernetes Service, and this is specifically useful if you have a very small team, or if you want to deploy your app, get all the benefits and the good things of AKS, but deploy easily, more conveniently in Azure. So today we're going to be talking about container apps mostly, and how to do it and all. So this is our agenda look like. So we'll tone it down from very basic. We'll go from what microservice is, how Kubernetes came into the picture, what is container apps, what are the advantages you get, and then we'll do a small demo and deploy a small app and see how it performs and what are the features that are there you can access through CLI, you can access through as a portal, and then probably if we have some question we can discuss on that. So myself, I'm Kunal Das. I work as a senior DevOps engineer at Syncly AI Innovation Center, and also I am co-organizer of Creative Switch India. Apart from that, I do certification and I am 7x Azure certified. So let's jump into the topic. So what is the microservice and how it came? Before knowing that, we have to understand what existed before. So when I started working and back in the day, it was mostly all the application were deployed in a monolithic architecture, where we have all the application packed in a single thing, maybe a Windows Server VM, or maybe whatever. In that server, you have the back end, front end, everything tied together, that accessing the database and fetching you the result. So basically, everything is unified. There are advantages and disadvantages of a monolith approach, but the more you grow into an app and you want to hyperscale your app, considering those in mind, as the user base grew more and more, as more people started coming in, then microservice came into the picture. And microservice basically takes an alternate route where it breaks down each individual program or each individual features into small chunks of basis. And basically you can think of like the three-layer architecture: front end, back end, or the middleware. Everything is broken down into small chunks and then deployed separately, and they interconnect with each other. The main primary benefit of going into microservice is basically, if you have a problem into certain thing, then you can quickly easily identify and replace that, and your whole application does not go down because one particular service is faulty. So that is the main advantage of microservice. Now coming to the rise of Kubernetes, as more and more people started using microservice, there was a need to adapt and manage the microservices altogether. And Kubernetes was a project by Google. Then it was open source on 2014, And then since then it was kind of industry standard. Many people started using. There are alternatives of Kubernetes, but Kubernetes is basically a container orchestration system which helps us to this small part that I was discussing, right? The small chunks of our program. It helps to containerize. If you containerize all those things and deploy it, Kubernetes helps us to manage all those things separately and create services, manage the network traffic, how it flows between them, and how you will interact with them. So all those things are taken care by Kubernetes. And by a recent survey in 2020, it was known that 83% of enterprises are using Kubernetes. So it is the de facto of container management system. And there are few things that K8s or Kubernetes offers. First is container orchestration, then automated rollouts, rollback, self-healing, and horizontal scaling. These are primary that I have noted down. There are many features that are there that is available with Kubernetes. And if we talk about Kubernetes, it is a like widely accepted thing, and Azure provide Azure Kubernetes service where you can easily create your Kubernetes cluster, and backend all your workload will run in different nodes, or also known as VM skill sets, and you can manage everything from your Kubernetes cluster easily. So Kubernetes is basically the de facto, as I was saying. So before we proceed, like, I would like to encourage the audience to just go ahead and understand, just scan this QR, and just what are the Kubernetes feature you like most? I believe everyone has one way or another used Kubernetes or heard about it. So if you can just quickly tell me, like, what are the features that you think is the most attractive of Kubernetes that you like? So yeah, we got one, scalability. Definitely scalability is nice feature that we have in Kubernetes. High availability is another one. Yes, correct. Resource optimization, and ingress. Yeah, ingress is also another good feature of Kubernetes. So yeah, these are there are a few features that people are mentioning. So loose coupling, yeah, because it is modular in nature, so definitely it has that feature. Orchestration is one, modularity, yeah. Isolation with namespaces, cool. Okay, I think we have a lot. Ingress, yeah. And load balancing, definitely load balancing is required. If you have multiple modular things, you have to load balance. So coming same thing, like what you guys have said, like I can broadly categorized all this thing into four parts, and definitely load balancing and all are definitely a very cool feature of Kubernetes. So the four part that I have what's a I have toned down is scalability, high availability, updates and rollbacks, and resource optimization. So let's look at all of them. In terms of scalability, if you look at any direct to consumer application, most of them are certainly not most of them, definitely a big chunk of them are built on Kubernetes. And the primary reason is Kubernetes is very scalable. It can scale down or scale up based on the load, based on the user demand and whatever you want to call it. And it is highly available because there are very minimal downtime, because it distributes the service across multiple nodes, regions, or fault tolerance. Everything can be done. Updates and rollbacks are definitely a cool feature of Kubernetes or benefit of Kubernetes. You can gradually update if you want. You can update in blue greens. That is also a good thing. And you can, if something goes wrong, you can easily roll back one by one, because everything is in small pieces. It is a lot easier to handle. And resource optimization, when you deploy suppose you have a developed one website and you deploy it into a VM or something in a monolithic approach, you can't really it is very hard by default. You can't do something like that. I want this application, the front end, to use only this much of memory, this much of CPU uses, everything. And now more and more AI things are coming, so also you can't really mention like, okay, I want this much GPU to be allocated what particularly for this purpose of our program. Kubernetes solves all those things. You can resource optimize properly and provide comprehensive resource optimization approach in your application. So these are few benefits of Kubernetes, but not everything is good. Definitely there are few problems that I believe everyone will agree with me. In terms of problem, sorry, there are operational overhead in scaling, so it does not automatically scale up and down. There are different way to scale: horizontal scaling, vertical scaling. You have your things like KEDA to manage scaling based on the loads, based on the request, based on the queue number, etc., etc. So scaling services manually or through scripts requires constant monitoring, infrastructure tweaking, etc. And it's hard to scale dynamically with demand sometime, unless you configure it to do that. And apart from that, as there are more services out there, when you go into a microservices architecture, into a Kubernetes architecture, like you have small chunks of pieces, then the problem is um, services, as services grow, then managing how they talk to each other, it becomes more and more complex. So so as they sorry so as they grow, it is a lot difficult to manage those services. And third point is deployment and rollback risks. So definitely Kubernetes by default provide a deployment mechanism and a rollback mechanism as well, but sometimes due to inconsistent bugs and whatnot, you have to manually roll back and manually deploy sometime, so that also requires headache. And resource management is a feature, and also I feel like it sometime can be a problematic thing, because managing CPU and GPU or memory for each of the resources, you have to define into YAML file and then deploy. So it's a hard to optimize resources. And all these things comes down to a thing like you have to need to have a expertise, opinion or expertise in knowledge in Kubernetes of a resource who will handle all these things manually, or maybe they will write the code, they will write the complexity parameters, everything to handle all these things, right? So to avoid all these things, if you have a small team, you do not need all the function or all the integrate butts and house in Kubernetes. Then the best thing to do is to move ACA. And let's understand what is Azure Container Apps. So Azure Container Apps is a serverless platform that allows you to deploy containerized application, and it is very cheap. So you do not have to worry about the control plane. You do not have to worry about the data plane as well. The thing that you have to worry about is your application, how you're going to deploy it. And once you deploy it, what the scaling rule that you want to apply, and once you set that, it just runs. And suppose there is a thing like demand based scaling, etc. All these things are handled by ACA completely. So underlying, it's a Kubernetes without the hassle of managing a Kubernetes service. Now there are several uses of container apps I have used for deploying API. And there are way you can have container app jobs which can work as a function app, but short-lived memory jobs which can act as a function app, but you can deploy Docker, everything, and you can add scaling rule as well. And then event driven processing, as I was saying, like KEDA, etc., which provides Kubernetes event driven auto scaling, are integrated into container apps, and also you can run microservices as well. So these are few features that container app offers. Serverless container hosting, automatically it handles infrastructure scaling and load balancing for containerized application without the needing to manage the Kubernetes or the VMs. So you do not have to worry about your system nodes, your data nodes, etc. And ACA handles everything and all the underlying architecture. There are only two things you have to deploy: one container apps environment and your container apps. That's it. And it builds in, as I was saying, it supports auto scaling, which is a very big thing. Setting up KEDA requires a few time and your efforts, and then you have to perform load balancing, etc., to make sure that it is working fine. So based on your CPU, GPU, even queue length or HTTP request per second, you can add those rules very easily with a one single command or two commands. Also for pub sub messaging and secret management, etc., it's all already possible, and it has a Dapr support. So Dapr is built in, integrated into container apps. So if you're using Dapr in your Kubernetes, then you can easily migrate to container apps. And also on top of that, built-in ingress and revision management. So there are two kind of ingress is there, internal and external ingress, or everything can be integrated easily within a click of a button. And if you want to do A/B testing or blue grid deployment, traffic splitting, everything is possible here. And it can integrate with DevOps. Definitely Azure DevOps, it can integrate, you can deploy easily. And also if you don't want to do a DevOps pipeline dedicated, it can integrate easily with GitHub Actions as well. So by integrating that, you push your code to main branch or whatever branch you want, and it will generate the container. And then once that does, it will push your container to your registry, and from there it will pull the Docker file or the container, and that it will start running. And the thing is, as all these things are doing, if you are doing in Azure, so you get the benefit of Azure, like the log analytics, key vault, everything is well integrated into it. So there are a few things that ACA as a provides advantage, which are little bit tricky to set up into Kubernetes primarily. So the primary advantages or key problem that ACA solves is like provides automatic scaling based on HTTP traffic. You do not have to have install any external third-party services like CADA, etc., and you do not have to monitor as well. It works as easily as possible, and also it scales down to zero when not in use, so it reduces the cost quite a bit. Now coming to the second point, services and communication overhead. The service discovery built in works flawlessly, and apart from that, if you want to have a private container apps, that is also doable. Now manage Dapr integration, I was saying, for standardized communication, secure communication, if you want to do, that is also possible. Now deployment and rollback, simplified CI/CD with version revisions. One-click automated rollback is possible because you from portal itself you can see, or CLI itself you can see all the previous revisions that are there. Suppose something goes wrong, just a click of a button you can revert to your old version. And also blue green canary deployment, all are built in. You can add labels into the containers or the apps easily, and you can roll back to them. So all these things basically helps or the advantage of container apps. Apart from that, there are certain things like resource management complexity. So in container apps, you can allocate resources based on CPU and based on memory limits per container easily when you are creating those. And basically that can automatically scale down to zero by default when it's not working. So these are the few benefits of Azure Container Apps. So now what I'll do is we'll see like how to get started into container apps. There are a lot of modules are there in Microsoft land, so I have built my own also. So to get started, first thing we have to do is set up the environment. So first, in Azure, whatever the resources you want to deploy, we want to deploy in Azure resource groups, because resource group is kind of a compartment where your all of the resources will stay. And also similar to suppose if you want to create a blob storage or file share, first you have to create a storage accounts, right? Similarly, if you want to create a web app, we have to create an app service account. Same app policy applies here. Whenever we want to create a container apps, you have to create a container app environment. One environment can consist of multiple container apps, and they are generally based on the same or different location as well. Then second step is you create a Docker file, and then you push the Docker file into a container registry, be it Azure Container Registry or Docker Hub, and then you deploy your container app. The container app will pull from there, and that is it. These two steps are more than enough to deploy your first app. But if you want to apply certain rules and all, that is also possible, both via GUI Azure portal and also via our Azure CLI tools. So once you get the URL, you can just access it and use your app as it you want to. And also if you want to set up some scaling rules based on the HTTP traffic, based on the queue, all those things are possible. So now I'll show you some demo, like what are the things that I have done. So I have pushed this code. This is already available in GitHub. I'll share the link on the comments. So this is a very basic app that I have developed and just yesterday. So if you see, the index.html has a front end code, and apart from index.html, I have created a README which has all the commands, so basically how to build it locally, how to run it locally, etc., etc. So the app actually looks, let me see if it's running or not. No, it's not running. So yeah, not a problem, I can run it again. So basically the Docker file that I created is also very simple, just an Nginx web server app, and then I'm copying the index.html, and then I'm exposing port 80, and then I'm just starting the server, which will just point to that the Nginx will point to this HTML and it will show. So now if I want to deploy this app into container app, there are very easy to do stages are there. So this is the app actually look like. If you see it, it already deployed into container app, but I'll show how to deploy it again. So the steps are very simple, as I was saying. First, these are like one extension that you can add into, you have to add into Azure CLI if you want to Azure CLI. And then once your the setup account, everything is done, I have created a resource group. I have created this is a provider registration. I have created a container apps environment. So let me just go back and show you. So this is the container app that is there that I have developed. And if we go into revision and replicas, refresh. So if you see, the app has been scaled down to 0 because I'm not using it. I was not using it. So now if I refresh it, it will still refreshing, and if I refresh this page in portal, you will see it starts activating. So I have set up some rules which is actually acting in a backend and scaling up and down based on the load comes. We'll come back to all this later. So the step to create is, first we'll create a container apps environment. That environment will host multiple apps, and then secondly what we'll do, we'll create the container app. And once we have the container app, then most of the thing is done. We can deploy any app into that container app, and it will serve all the traffic that are there. So first what I'll do is I'll just run the same Docker image that I've created. I'll just try to deploy it. So the command is kind of like this. So first is it container app create, and then the name I'll pass of, and then definitely the resource group I have to pass, or maybe let me just quickly copy paste, it would be much easier. The same command I am passing, this is the command. So now let me just explain this command in a detail. So first I am doing the same command, container app create. I am passing the name of the container app, then the resource group name where I have the container app, and then the environment name. Then I'm passing the image. So this is in Docker Hub, as you can see. So I'm passing the image name. Then the replica I need, I mentioned at 0, so it will scale down to 0. Maximum replica that I need is 5. Scale rules. So this is the important thing. I'm using KDA in using CLI kind of a thing, you can say. So I'm setting up an HTTP rule. That HTTP rule type is HTTP. It can be a queue, it can be a blob storage, whatever. And the scale rule type concurrency is 3. So more than 3 requests, it will scale up another revision. And then the target port I've set as 80, and ingress type is external. It can be internal as well. And then I'm passing the query parameter to get the front end URL. So once I click on it, this will start creating the container apps based on this image, this image that I have pushed into Docker App. and the whole thing can be actually automated also. So once you push the code into your branch, it will start working and it will deploy automatically. So all this thing can be done. We'll show. So as you can see, container app is created. Access your app at this particular URL. So I'll just copy the URL from here. It's essentially the same URL. So we see this is a basic codes app. If you click the new code, it shows a new code, and it has the color changing ability, etc., etc. So you can change the color and whatnot. And so this is it. And now let's check what are the things that are there. So if I refresh it, it will show that this is the revision that is running. And if I go into inactive revision, it will show all the revision that I deployed previously. So suppose if I want to activate a previous revision, I can do that from here. And in this section, it will show all the replicas. Now suppose I want to see what are the logs of this application that I have deployed. So that can also be done easily. I'll just run this command to see the logs. So as you can see, twice I refreshed, all the logs are coming here. And even not only that, we can see the system logs from here. Now let's go one by one, different feature. Let us explore. First is this containers. Here you can see all the container you deployed. So this is the registry login server, the image and the tag. We can use both Azure Container Registry or Docker Hub, etc. Here you can pass all the environment variable we can add, and also not only just adding here, we can easily use Azure Key Vault and integrate with Key Vault secrets. We can add liveness, readiness, all the probes that are there, and volume mounting also. We can mount any file share easily here. Now coming to the scale part, this is the rule that I have set. Minimum replica is 0, maximum is 5, and cooldown period is 3 seconds, and then polling interval 30 seconds. So current number of replicas it shows, and there this is the HTTP scale rule that I have selected. So as you can see, there are as you queue custom rules are also can be doable, and concurrent request based on the value that will work on the HTTP scaling part. Volume is here, you can connect any files here, and that you can attach to your container. On top of that, it provides authentication part. So I have also done that previously. It's not scope of this demo. So here you can select any authentication provider if you want to have authentication for your app, that can also be easily integrated. So you just select Microsoft and select some app registration, or it can create a new one for you, and then that app will be used to log in into your app, and then you can easily work on that. Secret is a global secret part, where you can add your own secret manually or same via key vault reference. You have to provide the versionless ID of key vault, and that works. And then as I was saying, the ingress part, so there are two kind of ingress. This is the external ingress that I have selected in the command prompt. Apart from that, we can also do internal ingress. If we do internal ingress, then the application will only be available into all the application that are deployed into the container apps environment. Suppose you deploy front end, back end, middleware into container apps environment, everything will be available via the internal ingress. And maybe one application, the UI part, you want to keep it external, and rest of the app you suppose generally we keep at a internal level. That can be done here from here also. And if we switch to limited to container apps environment, the URL changes and one internal word gets added before the name of the app. And from here you can set the port and everything, and IP restriction, all the thing is doable via CLI or via GUI also. And deployment, as I was mentioning, here you can select any GitHub account and your repo, your branch, and once you push something, it will take from there and it will deploy to Docker or Azure registry, and then it will get integrated into container apps. So there are several features. As you can see, Dapr is also there, we can enable from here, and we can add custom domains, and all those things get integrated into Azure ecosystem. So we can easily see log stream from here also, that I ran command. So not only the console logs, console logs is visible here. We can also visit the system logs also. So whenever the container app ready or container app dies down, we can get the logs, and all these logs get stored into Azure Log Analytics workspace. So we can run KQL query, get the logs easily, and we can set alert also. So that is also is easy to do. Now let's go. These are the thing. Let's go back to our slide. So yeah, these are the things that you need to set up. So there are some advanced features that I particularly want to discuss in ACA. I was just discussing while showing up the demo. So you can easily mount your volume. No need to install any external storage class, etc. It's very easy to do it. It seamlessly integrates with Azure file share for persistent storage, and that file share or that particular file share will get mounted. The secret can be in Azure Key Vault. And so the overall thing that Azure Key Vault integration is very good. You can integrate with Azure Enter ID for your login authentication purpose of your app. It's suppose easy or 2.0, and seamlessly connect with Key Vault for secrets management and log analytics for logging, alerting, etc. And also there as I was showing, like GitHub Action, by default it supports GitHub Action, so you can easily connect with GitHub Actions. And these are few of the advanced features. On top of that, definitely we have Dapr support, we have KDA support, and the list is growing more and more. So to deploy any application or any container based application where you need HTTP scaling, or you need a Azure queue based scaling, etc., it is a lot more easier to do. Unless you want to dig deep and hyperscale, then it is very easy to just play around with container apps and deploy. And also in some slide, I guess I have mentioned, it provides some, Azure provides some free credit to try on in Azure Container Apps. That is a good thing. Now I would ask, like, if you have some questions answer, please scan the code or maybe drop in the comment section. I'll try to answer, and I'll start taking some questions. So let me start. Is AC a feature of Kubernetes? No, this is a different service altogether. This is the Azure Provide service, which actually abstracts quite a lot of things that Kubernetes does and makes them easy for us to handle. What was? Let me see if there are some other questions. Yeah, you can definitely drop on the YouTube as well. Not a problem. What is the ideal workloads for ACA? So the ideal workload is basically, if you want to use the benefit of Kubernetes without the hassle of setting up, then it is very easy to play around and set up using the portal. I think you will agree, or the CLI, and not like go around and select a compute. And it is actually a lot cheaper. So if you have a small team just starting up, then ACA can do most of the job, and it is very easy to, if suppose you grow in future, like it is very easy to go from ACA into Kubernetes later on, because essentially you are all deploying a container based job, right? So that is also a good thing. So from starting out, I would suggest, if you are starting just out, you have a small team supporting 100 200 people, then ACA can be sufficiently usable for that part. You can easily create some good dashboard of the users dashboard, etc., using log analytics, etc., and then just get around with it. Can ACA support some of the Kubernetes object like cron job, daemon set, stateful set? No, these are core core Kubernetes object like cron job. Cron job is not, daemon set and stateful set are core Kubernetes object. These are by default not supported, but it is not required to do also. So stateful set and daemon set you use when you deploy something in Kubernetes and you need the statefulness thing, right? Or you want to schedule something, then you set up a cron job. There is a thing called Azure Container Apps jobs, which does the same thing like cron job, and that also is supported with the event-based scaling. Does ACA support config maps and secrets? Yeah. So as I was saying, maybe I can show again. So if you see, if you go into the secret part, that is definitely a secret, and you can fetch it as you key vault. And inside the container tab, there is an option where you can easily set the environment variables, which actually act like a config maps, right? So you can put all your variables secret easily. And no need to actually create a new config map or new secret. Then maybe for key vault also you need to install third-party tools. So no need to do all those things. It is by default integrated, and it works flawlessly. Yeah, I'll Does ACA allow to have RBAC enabled restriction to workloads similar to Kubernetes? See, when you are working in Kubernetes, you can definitely do this thing, right? You can have multiple namespaces and allow one teams to access particular namespace using RBAC and whatnot. But ACA is a much toned down version of that. So if you have a container app, that basically means your pod, right? And that pod, if you want to have a authentication for the end user to log in using Azure credentials or Google credentials, that is doable. As I was showing, like, it is doable very much. But if you want to suppose block access to a container app for certain team members, then that is doable via by default Azure access control or IAM policies. So you can easily, similar to what we do any other Azure resources, we can also use the same thing into here also and restrict the user access to for the particular thing. Any more question?
Final call to drop all your questions. So I think we are good. Let's
Yeah,
call for
yeah. Lot of good questions actually, and thanks for asking question. Is there guidance to migration also to ACA? So there is no such guidance actually. See, get started to ACA is very simple. There are Microsoft modules, I think, attached on the description of the video. You can follow along, or also the repo link I'll also put in the comment, so you can follow along to deploy any front end app. It's easily. And once you grow out of ACA, then definitely it is much more easier to move to AKS, because essentially all your containers are there, and you can just use those same container to deploy into AKS. You just need to set up all the things that you have already doing into ACA. You just have to set up all those things into Kubernetes. So it is not very hard to, I would say, to move out of ACA, and because essentially it is following the same architecture, just giving some abstraction and helping us to deploy and take advantage of some few of the important Kubernetes feature easily. So yeah, I think Parth, I think we are done with the questions, right?
great.
Yeah. So that is it from my side. Like, thank you for joining. If you have any question, put in the comments. I'll be able to answer those later onwards. And if you want to connect with me, feel free to do so. I'm available on LinkedIn as well. So yeah, thanks for putting in the effort to listen, and I hope you learned something. And thanks for Microsoft Reactor for giving me the opportunity to share about container apps. So yeah, thank you, Parthas, also.
Thank you, Kunal, for doing this. And thank you, everyone. Hope you all had a great learning. There are the Learn module links shared in the chat. You please go through it and take your learning further from there. And you'll have more questions, like mentioned, Kunal. Please reach out to him over LinkedIn, and he can help you more with the great learning links and with the more. Yeah, thank you. Thank you, Kunal.
Thank you.
Thank you. Thank you so much. Thank you.